Hi, I'm Simone Foti from Imperial College London, and in the next 5 minutes I will quickly drive you through this exciting work that I conducted with Stefanos Tsafirio and Tolga Birdan. As you can see from the title, we propose a new method to generate textures without UV mapping, and we do this with a denoising diffusion model which leverages heat diffusion to spread information across the surface of each object. Before we even delve into the technical details of this work, I would like to discuss our motivation. So imagine this scenario for a second. You are a sculptor, and you're a great sculptor who have just carved a beautiful statue. Now you want to color it, and my question is, how do you color a statue? Well, the answer is quite simple, right? You could use decoupage. You could take a piece of paper, you could paint on it, and then you could try to stick it on the surface as well as you can. But is this really what you would do? Is it really the best approach? Or would you rather take a paintbrush and paint directly the surface of the object? I hope you all agree with me that the second approach is the most logical and hopefully also the best one, right? So why is the whole community trying to do something very similar to decoupage and use UV textures to represent the object colors? This also comes with a lot of limitations, which are ranging from seams to distortions, wasted UV space, and also varying resolution. So it really is not a good representation. In this paper, we advocate for a different representation, which is more similar to painting with a brush, and which uses colored point clouds to represent textures. In this work, therefore, we generate unstructured point cloud textures directly on the mesh surfaces and avoid UV mapping. And what is important to note here is that even if we use colored point clouds to represent textures, we create a neural network that operates on the surface of the mesh by leveraging both geometric and topological information from each object and ensures that informations are geodesically spread across the object. We call our model UV3TeD, which actually stands for UV3 Texture Diffusion. As we previously said, this is a denoising diffusion model, and the core building block is based on heat diffusion. We improve upon the operators initially proposed by Sharp et al. In 2022 by, initially adding more layers, but more importantly, we had a whole new branch, which we call the farthest sampled attention branch. As you can see, this new orange part is subdivided in 3 blocks. The first one is a heat diffusion operation responsible for spreading information across the entire surface of the object. We then collect the information which was spread to the whole surface at specific locations, which are the farthest samples, and we process it with a multi-headed self-attention. Then we spread it back, the information which was processed by the self-attention, from the red dots to the rest of the surface with a second heat diffusion operation. These attention-enhanced blocks are then repeated several times and interconnected in a U-net-like fashion. Together, they form the main architecture of UV3TeD. And if the attention-enhanced blocks were our first contributions, our second contribution is our online sampling strategy that allows us to sample point clouds and their spectral properties during training by leveraging quantity pre-computed on the input meshes. Our third contribution is a simple yet essential modification to the way we diffuse heat on the surface. So we noticed that if we were using just a mesh Laplacian, in the presence of disconnected components or topological errors, heat was not diffusing properly. So we decided to mix this Laplacian with a point cloud one, and we actually solved the problem. And you can see here that now heat diffuses properly, also with topological errors and disconnected components. If we now look at the results, the first thing you'll notice is that unlike other non-UV based methods, we're actually capable of generating realistic textures on multi-class datasets like APO. If you then compare our performance against the best-in-class non-UV based method currently available, you may notice that UV3TeD can generate more diverse samples which are also capturing the semantics of the different object parts. And this is proven not only in this qualitative evaluation, but also in a quantitative one that you can find in our paper. So if you're interested in learning more and delve deeper in the technical details of our method, I encourage you to scan this QR code, and more importantly, to drop the UV and generate with UV3TeD.